Okay, so this lesson is going to be an integer arithmetic review. So you'll find that when you're doing your algebra, you end up doing a lot of mental arithmetic. Yes, you can use your calculator for many of these problems, but being able to do some of this basic mental arithmetic is going to really help you out. So I'm going to remind you of some of these rules. So this first one is going to be when we're adding the same signs. So if I have, for instance, -7 plus -5, when we're adding the same signs, we add the numbers and keep the sign. So a -7 plus -5 is just -12. We simply add 7 and 5, and we get 12, and then we keep the negative. One way to think about this is in like debts. You owe Bob $7, you owe Mario $5, you are in debt $12. And of course, 8 plus 2 is 10. The problem's almost never when you're adding two positive numbers together. It's almost always when we have negative numbers or one positive and one negative. So let's focus on that. So again, we have one rule where we have the same signs. The second rule is when we have different signs. So what do we do there? So practically what we do is we subtract the absolute value of the numbers and then keep the sign of the larger absolute value. That sounds confusing the way it's said. Let's see how this works in practice. So -4 plus 9 equals 5. Why? Well, 9 is the larger, and so we basically just say 9 minus 4, we get 5. Now what about 6 plus -10? So 6 plus -10, we subtract these two. 10 minus 6 is 4. But because the 10 is negative, we get the negative here. All right, so another way to think about this and sort of visualize this is on a number line. I really recommend that you do this. So we start with 6, and I'll often put a 0 placeholder there just to kind of balance myself out. And we're going to go, we're adding -10, and so that means we're going to go to the left 10 units. So I'm going to subtract 10 this way. So if I go from 6 to 0, that's already -6, so then I've got to go 4 more to -4. So it's another way to sort of think about these. Okay, let's look at an example. So -12 plus 7. Again, we want to avoid using calculators on these. Maybe you can use them to check, but we want to develop sort of a mental model to where we can do these without having to resort to calculators. So -12 plus 7. When I'm doing this, I'm just going to say 12 minus 7 is 5, and I know it's going to be negative. So this is going to be -12 plus 7 is a -5. So let's use a number line to help us think about this. So here's our number line. If I start at -12, and I'm going to add 7. So if I'm adding 7, that means I'm going to go to the right 7 units. So I'm adding 7. So do I make it to 0? So I would need to add 12 to get up to 0. So I'm just going to add 7, and so that's going to get me all the way up to -5. Okay, how about this one? -20 plus -10. Recall when the signs are the same, we just add the numbers and keep the sign. So -20 plus -10 is going to be -30. And again, think about the number line on why that works out. If I'm starting here at -10, and I'm going to go add -20, that means I'm adding negatives, so that means I'm going to the left 20 units. Plus a -20. Well, where's that going to land me? 20 units from 10 is -30. Okay, subtraction is always a little harder than addition. However, I really recommend, instead of subtracting, that you actually add the opposite when you have mixed signs. Now, if you just had something like 9 minus 2, you don't need to do all that. You know 9 minus 2 is 7. But when we start having mixed signs, I really recommend saying a minus b is the same as a plus a -b. So -6 minus 3, I would rewrite that as -6 plus a -3. And we'll often put parentheses around that second one just for aesthetics. And now we can use our addition rules. We have the same signs, so we're just going to add the numbers together and keep the sign. So it'd be -9. This will really help when we start doing algebraic expressions that have variables. Okay, this next example is a subtraction. So -5 minus -2. And so what do I recommend do on this? That we change this. I'm going to rewrite this a little bigger so I can work with it. So -5 minus a -2 equals -5 plus a +2. So those are exactly the same thing. And now it's a little bit easier for us to do. We know we're going to say 5 minus 2 is 3, and we know that's going to be negative because we take the sign of the larger absolute value number. So another way to think about this, again, is on the number line. We're starting here at -5. If I'm subtracting a -2, it's the same thing as adding 2, and so I'm just going to go over 2 units, and that gets me to -3. Okay, this next lesson is on multiplication of integers. In fact, this works with more than just integers, but we're just going to focus on integer because we're looking at mental arithmetic here. So a positive times a positive is a positive. I don't think that is anything new. If you said 3 times 5, you'd say 15. It's when we start having different signs. A negative times a negative is also a positive. And then a positive times a negative or a negative times a positive is a negative. So in general, if you have an even number of negatives, it's going to be positive. If you have an odd number of negatives being multiplied or divided, it's going to be negative. Let's see how this works with some examples. So -6 times 4. So in my head, I'm just saying, what is 6 times 4? Well, 6 times 4 is 24. And I know I have a negative times a positive, so that's going to be a negative. This is not a full explanation of integer arithmetic. We're just kind of reminding you of the basics. -7 times -3. So in this case, I'm just going to multiply the numbers together, and I'm going to get 21. And then negative times a negative is a positive. If you want to emphasize that, you can put a plus there, but that is not needed. Okay, the rules for division are very similar to multiplication. If I have a positive divided by a positive, it's a positive. 2 negatives being divided is a positive. A positive and a negative, or a negative and a positive, is a negative. So again, our same rule sort of applies here. So a -20 divided by -5. What do we get here? In my head, I'm just going to say 20 divided by 5 is 4. And I have a negative divided by positive, so it's a -4. Now, I'll be honest, sometimes I go ahead and do the sign first in my head. I'll see, okay, I know my answer is going to be negative, and then I work with the number. Okay, next example, a -28 divided by -7. And so we have an even number of negatives, so I know the answer is going to be positive, so 28 over 7 is 4.